Hello, everyone. Thank you so much to join us and skipping your lunch. Welcome our session. My name is Betty Zheng. I'm a senior developer advocate and come from AWS China developer relationship team. As developer advocate, my job role is to empower developers to maximize the benefit of AWS technology and services, like AWS Lambda Web Adapter we will talk about in today. I'm so excited to co-present with Harold Song. He's a senior serverless specialist SA and comes from AWS China too. Harold Song is not only the original creator of Lambda Web Adapter and also play a huge role in rolling it out. Harold will bring his real-world expertise in our topic today. Our goal is to showcase the potential of Lambda Web Adapter and demonstrate how it enables developers to run a serverless web application like never before. Okay, in today, we will provide the practice guidance and real-world example to unlock all capacity of Lambda Web Adapter. Our story will begin with challenges of building a serverless web application. And then Harold will share his story on inventing AWS Lambda Web Adapter and his experience in the migrating web app to Lambda and enhancing Lambda runtimes. In the final segment, we will summarize the benefit and the possibility of Lambda Web Adapter by developers' voice and their experience on unlocking serverless web application. Okay, let's go to our first topic of the challenge of building a serverless web application with AWS Lambda, AWS Lambda, as we know, it's a serverless computing service by AWS. It gets rid of server management and offers scalability and cost saving. It's triggered by event and run in the stateless way. So we heard some developers, they share some challenges they faced. One challenge is adopting the different programming model, which require a shift in coding mindset to handle event and manage statelessness. In addition, some developers find themselves struggling with availability of development and debugging tools. They may feel less familiar with this tool for Lambda than those tools for containers. Despite they face these challenges, developers also recognize that migrating web application to Lambda, it will bring some more exciting opportunities and benefits for them. But we notice that all this migration from web application to Lambda or Lambda to container will put in extra work and more code modifications. So in the next section, we will talk about what's extra work or code modification this difference entailed. Okay, Lambda programming model. Lambda are based on the event-driven programming model. Instead of question-sponsor style, Lambda programming model all about runs code in response to a specific event. It includes changes in data state, request to endpoint, and changes in resource state. As event happened, Lambda function are triggered automatically and run in the stateless environment. So developers can write code, don't worry about managing underlying infrastructure and managing the persistent state between invocation. Lambda programming models support multiple programming languages, such as Node.js, Python, Java, and Extra. So developers can choose their familiar programming language to build their Lambda functions. Okay. Lambda function here is a code for Lambda function, yes. Lambda function require a specific handler function as an entry point to receive and process data when it's triggered by event. Handler function usually receive event object and invoke context object. Event object contain data payload received from triggers in Lambda when it serves for a various type of events. It's include but not limited to HTTP request, custom event data, and message from event source like the Amazon SQS, Amazon S3. Context object provide a runtime information like the HTTP ID, request ID and function name and extra. It facilitates the interaction between Lambda function and its execution environment. Okay, after a standard Lambda function, let's take a look at a code example for HTTP Lambda function. It showcases how Lambda function handle HTTP request. Lambda handler function will receive event payload as an input and extract detailed information about the request. In here, there are the method, parameters, body. It uses this message to process request and execute data operations. After processing, function construct the response and return it to caller. Adopting HTTP Lambda function, developers do not have to set up hard parameters of setting, maintaining, managing server. It just focus on the right business logic. However, we also have noticed that the code of HTTP Lambda function is different from the usual code of handling HTTP request in Lambda, in a web application. Okay, due to the difference of the programming model, developers need to understand more new processing methods to specify their run a serverless web application. So they think for solution or tools to lessen these differences. We can see some developers using a framework-specific adapter to deploy existing code as Lambda function. Here's a code example. That's a fast API application. It's used migrate to adopt it for running in Lambda. Migrate is a Python library. It wrapped fast API application into a handler function and transform event payload to the required format for fast API. Okay, migrate is a convenience tool for developers. It simplifies the process of deploying web application to Lambda seamlessly. But also we should hear some developers express their consent. This adapter package have some drawbacks. For example, developers should code modificate to add a new dependency. In addition, developers some concern about the long-term maintenance of these adapter packages. It will result in the potential stability, version capacity issue of difficult to independency management. Like the Mangan, there are the other popular adapter packages like AWS Serverless, Java Container for Java, AWS Serverless, Express for Node.js. Okay, So our business run web application should on the container, EC2, or Lambda. But developers realize that is very difficult to lift and shift application to Lambda without any code modifications. Actually, moving the application to Lambda needs code modification to create a handler function, or you can leverage adapter packages to create Lambda function. Or also, we achieve workload portability from Lambda to container require a large code modifications. Because of this difficult, some developers deploy their web application with Lambda just for their free will apps. So developers want to know, is it possible to package our doc image into, package our web application into a doc image and run it anywhere without any code modification? Answer is yes. Today we can use Lambda Web Adapter, do it. So in the next section, I would like to invite Harold to share his story on inventing Lambda Web Adapter. Welcome, Harold.
Thanks, Betty. I'm Harold Sam, a senior serverless specialist, I say. I've been working with customers to move to adopt serverless and Lambda for many years. A lot of first-time developers who is new to Lambda, they told me, his question is, usually this question comes out a lot. I got it, Lambda and serverless are great. It's fantastic. They scale up and down quickly. I don't need to pay for idle. I don't need to manage servers to run my code. However, majority of my applications are web applications, like 70 or 80%. And I have a bunch of web applications that's already created. How could I move those into Lambda to get benefits from serverless? So that's those questions are starting point to get us to think, is there a way to help developers to move web applications into Lambda without a major change of code? In 2020, during the reInvent, Lambda service launched OSI Docker image support, which allows people to package their function as a Docker image and deploy on Lambda to create a function. However, that can allow people to quickly package their applications, deploy large dependencies, but that does not change Lambda's programming model. You still need to have a handler. You still need to pass those event sources. But after several months, there are amazing proof of concept demos coming from Aidan Steele. He created a serverless-ish demo, which basically wrap a Golang web function, web application in a Docker image and put it in Lambda without changing that code. It is amazing to see that is actually possible. And after a while, Apparent Order also created a project called ReWeb. It's basically using a slightly different approach to do the similar thing. However, these two projects are POCs and did not really continue to build into production-grade products and tools that people can use. So what we have decided to do is invest time and energy to create the AWS Lambda Web Adapter. This is an open source tool that is going to allow developers to run your web application on Lambda without changing your code. It is basically a generic adapter between Lambda's runtime API and HTTP API. It supports API Gateway REST endpoint, HTTP endpoint, Lambda function URL, and the application load balancer. Web Adapter would automatically transform the event payloads from these triggers and convert that to HTTP requests to your application. In this way, you can use your familiar frameworks and language to develop any web applications and run that in Lambda. You don't need to add new dependencies like Magon or serverless Java container or serverless Express to do that translation for you. And this one allows you to use your existing tools to do local development and debugging. And the Web Adapter also supports you can use Docker image to package your function. You can use zip to package your function as well. It runs on Intel CPU. It also runs on Graviton. Let's look deeper how this thing works. This is one of the Lambda's execution environment. Inside it, on the left, there's Lambda's API endpoints, like runtime API endpoints and extension API endpoints. Web Adapter is sitting between the Lambda's API endpoint and your web application. Lambda Web Adapter is an extension, Lambda extension, and also a custom runtime. As you can see, Lambda Adapter is sitting in the data path on every request and response. So the performance is very critical. To get the best performance, we choose to use Rust to build Lambda Web Adapter. So there's a custom runtime maintained by AWS teams called AWS Lambda Rust runtime. And adapter is basically, you can consider it as a Rust function, Lambda function. So with Rust, we are able to achieve very good performance for Web Adapter. Usually it's, we see about latency like 1 milliseconds to do the request response translation in the Web Adapter. And here's a detailed sequence diagram that shows how things works. When a Lambda service created an execution environment, it will automatically start all the external extensions, and Web Adapter is the extension. So it will be automatically started by Lambda service, and when Adapter starts, it has a backend threads just register itself to the Lambda service, so that Lambda service knows the extension has started. Once that register is finished, Lambda service will continue to start up your Lambda runtime process. Here, we have some tricks to let Lambda start in your web application instead of the runtime process. The detail we'll explain later. And once your web application process gets started, Web Adapter will do a readiness check or health check on your web application. By default, it's going to send HTTP GET request to your local process on 8080 and try to get the root path. If your web application is started and returns, let's say, response in 200 to less than 500, Web Adapter will consider your application is ready. You can change these configurations. You can change the port and the readiness check path, and even the source code range, you can change that. But once the application started past the readiness check, Adapter will inform Lambda service that everything is started. It's good to send invokes. Then your application, Lambda will send actual HTTP requests, those payloads, to Web Adapter. Adapter will take that payload, let's say it's coming from API gateway. It will get a JSON payload with all the past HTTP request information. And Adapter will convert that JSON into a real HTTP request and send to your web application. so that your application can handle that request and return HTTP response. Adapter receives that HTTP response, and it will convert to the JSON format that Lambda service expects. With this invoke cycle, you can continue several times or many times. There's another benefit of having Web Adapter as a Lambda extension. Because if you have a Lambda function with extension attached, Lambda service actually enables a shutdown phase. So when that Lambda execution environment got recycled, Lambda will send a SIG-term message to your web process and allows you some time to run cleanup code. Let's say you can close database connections or release distribute logs. So in this way, you can do graceful shutdown. With that, here's an example of how to package and run an Express.js web application on Lambda. This is basically a very simple, typical Express.js Docker file. You take a Node.js base image and copy package.json, install the dependency, and copy the source code over, and use run command to start up your Node.js process. There's one line in the Docker file which copies Web Adapter's binary into the Docker file under a very specific directory called opt extensions. All the executables under this directory will be treated as Lambda extensions by the Lambda service. So if you build a Docker image with this Docker file and create a Lambda function with it, and when this function starts, Lambda will start the adapter. At the same time, the same image can be used to be run on EC2 or run on ECS or EKS. Because outside of the Lambda environment, the web adapter in that specific directory will not be run by anybody. Outside the Lambda environment, Docker will run your application based on the entry point and the command parameter, right? So this is how we use Web Adapter in a Docker image format. There is a very quick example to see. The font is a little bit small. I'm just going to explain this demo. So we have a simple Express.js app with just a root path that returns hello world. And now we are starting a local development server with NodeMon. And we can do changes locally. And once we save it, we will immediately see the results. Here we are just changing the response of the root path and adding a log entry there. Once we add it and save it, NodeMon detect a change and reload the server. And we access it, the data is changed. Now we have very good local development experience. And here we wanted to add a new route. Here we are just entering a prompt. And we have Code Whisper taking a prompt, try to generate some code for us. This code will actually take parameter called name so that we can add the names so that this function can greet the names, right? So we say name everyone, and it's going to be hello everyone, and hello Raymond. So this is, shows us we can have a normal, efficient, local developer developing a debugging experience. Now, let's deploy this web application to Lambda. We're using Sans CLI to do this. So we run sans build and sans deploy. At the backend, sans build will take the source code and the Docker file to build a Docker image and push that Docker image into ECR, Elastic Container Registry. And we'll deploy a CloudFormation stack to use that Docker image in the ECR to create a Lambda function. And we can take a look at the Docker file. This is pretty much the one we saw before. It's just one line to copy the Lambda adapter binary there. And in the template file, this is Sun template. There is one resource called serverless function. And then we attached API gateway HTTP API to this function. Now it has been deployed. And we open the URL in the output. We got the exact same response as we got from the local development environment. And we can also enter the name, right? Hello, everyone, and hello, Raymond. So this demo shows us you can very quickly deploy a Node.js application into Lambda. You don't need to change any code. You just need to add web adapter. Okay? So another question I often got asked is the performance. We talked about it a little bit. We create web adapter using Rust because of performance. There's people still asking these questions a lot. There's a specific example on the project's GitHub repo. There's an issue, people asking, if I use Fast API, use UVCon to run a Fast API server, and use a web adapter, comparing that with use Mangang plus Fast API, how the code start will be like. We fully expect that with Lambda adapter, the code start time will be a little bit higher because we are going to start a full-blown web server. With Mangang, you don't need to do that. But we expect that it's not huge. Here's a test result. We run several hundred code starts to compare these two type of functions. The code start time between using Mangang and a web adapter is less than 100 milliseconds. So that really not significant for people's use case. And this is code start. And for one star, so meaning there's no code start process, the server is already started, the P50 latency is the same, exactly same, or very close between adapter and Mangang. So you can see from these results, using web adapter, the performance is pretty good. Now we see that you can use web adapter to deploy a new web application to Lambda without major changes. There's another chunk of existing web applications people want to migrate to Lambda to get the benefit of serverless. It was not really possible without changing code before because of the Lambda's programming model. But now with web adapter, you are able to do that without changing make significant changes to your web application. You can package your application, add an adapter, create a Docker image, deploy in Lambda function. To create a Lambda-less, this is the easiest path for now to move your application, web application, into Lambda to start to get the benefits for serverless. However, we also see other patterns. We see there is an evolution path. We would suggest that people to start with monolith, a Lambda-less, and when your application grows bigger, or your team grows bigger, split your monolith function into several microservices, so that your team can work on different services independently, and your services can use different languages that most suitable. And there's very specific cases, or it could be beneficial for you to move into single-purpose functions. Maybe not all of your application, maybe it's very specific part of your application, so that maybe your part of a function that needs super high performance. You can write it in Golang or Rust, and maybe that part of the function needs very specific, strict IAM permissions. You can create a separate function to do it. So this is we see the progressive ways to adopt serverless. Now let's look at an example of deploying existing web applications to Lambda. We see a lot of websites needs to process a lot of images. We need to resize those images to different resolutions to fit, let's say, laptop, iPad, and your phone, right? A lot of websites has millions of images, and to convert those images, resize them into different resolutions is very compute intensive and takes good time. And those images generated, it also have a storage cost associated with it. There is another approach that enabled by IMG proxy. IMG proxy is the Golang web application that can resize your images on the fly. eBay and Agolia also use this one. So you can use CDN, such as Amazon CloudFront, to request this IMG proxy, and IMG proxy will retrieve the original image from, let's say, S3, and resize it on the fly, and the results can be cached on the CDN, let's say CloudFront. You can cache it for a long time, let's say 1 year or even more. In this way, because IMG proxy can do the resizing very quickly, so you will get best of the both worlds. People can get fast response. The image can load quickly and can see the content quickly. And you do not need to pay for the extra storage cost and spend that compute power to do the batch transformation. There was an ask by the community to deploy IMG proxy on Lambda back in 2018, so 5 years ago. But IMG proxy uses a native library called libvips to do the image transformation. That has a dependency on a lot of native binaries. It's not easy to just deploy that in Lambda. So with Lambda Docker image support, it becomes easier. But still, the programming model is still a blocker. This year, somebody made it happen, actually without any effort from the IMG proxy maintainers. It only takes 2 lines to build a Docker file, then deploy to Lambda. As you can see, this Docker file is very simple. You just take IMG proxy-based Docker image and add the web adapter to it. Then build Docker image, deploy to Lambda, you got your serverless IMG proxy server. Okay? Another cases that we are looking, a lot of people are trying to do is for enterprise customers to move their existing Java or Spring Boot enterprise applications to Lambda. Because in enterprise applications, usually they do not have consistent workloads. They do not need to run very high concurrency stuff. It's very good fit for serverless compute like Lambda. But there was challenges to do that. Those applications are usually old and not easy to be modified. And Spring Boot is known for the cold start is bad. But the good thing is Lambda released the SnapStart for Java last re:Invent, and couple that with a web adapter. Enterprise customers can package their Spring Boot application into a Docker file, into a Docker image, put a web adapter in, enable SnapStart. They are able to run that in serverless compute without much trouble. And the cold start time is pretty good. And SnapStart is actually a technology that's based on Firecracker, microwave and snapshot, and restore. So basically, when you create a Lambda function with SnapStart enabled, Lambda service at the backend will start about several micro VM and then let your function init. So let your Spring Boot application to finish the several seconds or even 10 seconds cold start time. When your function's initialization finish, Lambda will take a memory snapshot of that micro VM and optimize that snapshot and store it. And when your function are actually invoked, Lambda function will quickly take that snapshot, resume your micro VM environment with your Spring Boot application already initialized, ready to go. And this resume process can take, instead of several seconds, it could be several hundred milliseconds. So this greatly reduced the cold start for Java. Now let's look at another demo of how we do this with Spring Boot, with Web Adapter, and put onto Lambda. This is a pretty simple pet store web application. It's a Spring one. There's a root pass and health check pass. Then there's also a pets controller, which provides API endpoints for you to create pets, get list of pets, or get one of pets information. So very simple one, pretty standard stuff. And we are going to use SAN, again, SAN CLI to build and deploy this application to Lambda. But there's one catch. SnapStart is not enabled, it does not support Docker image yet. So we'll have to use Java managed runtime. And managed runtime is only supported in the zip package format. So how do we run your web application and start the web adapter as a Java package? As a zip package. This is where the layer comes in. We also provided Lambda adapter as layers. You can attach that layer to your function. The layer contains a web adapter's binary and also a wrapper script. That wrapper script will, let's say, get executed during the init process to start your web application instead of starting the managed runtime. So here we see, this one is already deployed. But this one, we do not, this time, when we deploy this function, we do not enable SnapStart. And we run several hundreds of requests to do a small load test. You can see that there's cold start is around 5 to 6 seconds. And if we go to X-ray, we'll be able to see more clearly the cold start time. Yeah, there's several traces that you can see. There's the duration is 5 seconds or around 5 seconds. Let's open one of the trace. You can see here, there's a 4.8 or 9 seconds initialization. That is the time the Spring Boot application actually takes to start up. So without SnapStart, we see there's 5 or 6 seconds cold start, which is pretty bad. And now we enable the cold start for the version. SnapStart for the Lambda version, and we deploy it again. But with SnapStart enabled, Lambda will take a bit of time to create several execution environments and load your code, let it finish initialization, take snapshot, and also optimize those snapshot files. So this takes a bit of time. Usually takes 2 or 3 or even more minutes, depends on how long your application initialization takes. But with video editing, we reduce that time. So now we can see this application is deployed with SnapStart enabled. Now let's do the invoke again. It looks like it's under 2 seconds. We got results back. Let's do some load test. And the cold start time is less than 2 seconds, actually. So let's go to X-ray. We can find some details. Yeah, let's refresh the X-ray several times to get the latest traces in. It takes a little bit of time to get that. So there's one. And here you can see the whole code start time is 1.1 second, and there is no 4 second or 5 second initialization. There is only 500 milliseconds restore phase. That's SnapStart restoring your execution environment from the snapshot. So that's how long it takes. So this is comparing with 6 seconds, that's 1 second. It greatly improves your, reduce your code start time. Now, with this combination, enterprise customers can easily move their Spring Boot application plus web adapter. You can deploy to Lambda quite easily. Okay. Now gets next section. We have seen how to deploy new applications, web applications to Lambda, how to migrate existing web applications to Lambda. And web adapter can actually do a little bit more than that. Lambda launched response streaming at April this year. Response streaming actually allows your application to send response as soon as it's available so that your web application will become more responsive. It will reduce the time to the first byte. And the second advantage is you can return larger payloads than 6 megabyte. If you originally the Lambda only will buffer the response and only send it back. The buffer response, the largest they can do is 6 megabyte. Now you can go bigger to 20 megabyte, and if you need to go bigger, you can raise this limit. So people can use this function to return larger image or larger files through Lambda. And Lambda response streaming is only supported on Node.js runtimes and the custom runtimes. And on the trigger side, only function URL can do that. Or if you want to do, you can use SDK to call the Lambda function directly. API Gateway and ALB does not support Lambda response streaming yet. But as I said before, Lambda Web Adapter is actually based on a Rust runtime. Rust runtime is actually a custom runtime. So we can actually enhance Rust runtime to support response streaming, right? So what I did is we actually added this function into the Rust runtime. To do that, there's a specific format that you need to follow to do that for custom runtimes. There's several HTTP header you need to add. And in the payload, you need to have a JSON structure that specify the HTTP response header, HTTP response code, and HTTP cookies. And you need to add 8 null characters as a separator, and followed by chunk response bodies. With this, you are able to do response streaming on custom runtime. If you are custom runtime developers, let's say PHP or C++ or C, you can use this format to implement response streaming. So Web Adapter is already done this for you. Now, here is an example that we run a Next.js application on Lambda with the adapter with streaming response support. So this way, you can see this page comes back with product information and with recommended products and the reviews coming back later. Those are intentionally delayed, like 5 seconds for each. But as you can see here, you are able to quickly see the results without waiting for all the data is available. Another benefit for Web Adapter is that Web Adapter work for a lot of runtimes, not just Node.js or Java. It can work on Python runtime. It can work on Docker image. It actually works on the latest Amazon Linux 2023. The reason is Web Adapter is a Rust binary, and we do static linked combination with Muscle. So that binary does not have any dependency. It does not depend on libc versions or those stuff. You could put that binary into a Scratch file without operating system, it can work. So it is very easy to deploy to all the other runtimes. Here is an example that we create a Python function, let's say fast API, and do a call to Amazon Web Bedrock to generate some response as a stream, and stream the response back via the adapter and the function URL to your clients. So in this way, you can quickly create a serverless chatbot to create a generate app. Now let's look at this demo. This is a serverless a bedtime storyteller. You can enter a topic, and the application will ask the Bedrock, using Cloud 2, the large language model, to generate a bedtime story for you. Yeah, as you can see here, the results are coming back as a string. It's not coming back as a whole, right? So this is a streaming response. You got a much better chatting-like experience. Okay, with this demo, you can see here, we are in the send template. There's an environment variable that tells the Web Adapter that they should enable streaming. And the function URL also need to be configured as a streaming. With those two configurations, there is a fast API function. It has a route and a demo. Demo path will return the HTML and JS file. And there is a API route called API stories, which takes the topics you enter and create a prompt and invokes the Bedrock with the response streaming. Then they have a yield function to create a generator function, then stream the response back. This is pretty simple, fast API, work with Bedrock. And here is a front-end JavaScript file. There is a function to take the input we put into that input box and invoke the backend API, post that input to it. And here we are using readable string instead of server-side events, because that only does not allow you to do post. You can only do get. Now, using fetch, we can do the post and get the results back and update the web page as we got the results back. Okay, so this demo shows us Lambda Web Adapter can actually enhance the Lambda runtimes. It can add response streaming capabilities to other managed runtimes like Python or Java, right? So that's all for my part. Let's Betty. Okay.
Thank you, Harold, sharing. Lambda Web Adapter unlock the untapped potential of serverless web application. Okay, Lambda Web Adapter it's a game-changing tool for developers. It extends the programming model and allow developers use their familiar framework and tool to build a serverless web application without any extensive code modification. It acts like the bridge between the web application and Lambda. It's resulting smoother and faster processing, migrating processing. With Lambda Web Adapter, developers can get the flexibility to deploy their application into the different environment, depends on their specific requirement. Yes, we can, because of Lambda Web Adapter, developers take advantage of benefit provided by both serverless computing and containerization. It minimizes the need for extensive code modification. Okay, Lambda Web Adapter is an open source tool for developer. It has become very popular among developers from its increasing number of downloads. Okay, total download from Amazon ECR public tripled in 5 months and served 100 million invokes every month. Okay, we heard directly from our value customers about his experience on Lambda Web Adapter. Effie, he told us, when people want to move their existing Django applications to the cloud, I always recommend AWS Lambda with Lambda Web Adapter. It allows them to use familiar tool while benefiting from scalability and cost saving of run on AWS Lambda. King Colin, he's a principal engineer from Custom Inc. He said, thanks to the Lambda Web Adapter, I have more reason than ever to make AWS Lambda my compute platform of choice for containerized, full stack, web application framework such as Rails. I promise you, this is going to be huge and never be more happy to delete custom integration code thanks to AWS. Okay, in the last, you can scan QR code for the detail about our talk about resource. It's a Lambda Web Adapter, GitHub RIP, and 2 blogs talk about Lambda Web Adapter best practice. And before you leave, please help us to complete the session survey. It's very, very important for us. It helps us to improve our content and deliver high quality session in futures. Okay, finally, let's keep increasing the benefit of Lambda Web Adapter. We look forward to witness you create an incredible solution with AWS Lambda and AWS Lambda Web Adapter. You can follow the other exciting topic in tomorrow. Okay, thank you again. Thanks for your coming. Enjoy your time at re:Invent 2023. Thank you.